Hello everyone, myself Yogeswar Malepati with ID 11175693. I'm here to present my final presentation in IDT 8550 Deep Learning with Big Data. Here the process about building convolutional neural networks completely from scratch using TensorFlow low-level API. Here I didn't use any zeros or any pre-built model functions from the layers to the training loop, which was coded manually. Because our main goal was to classify images from the Cipher 10 dataset, and it has 10 different objects categories like airplanes, dogs, ships, horse, and many more, etc. And it will be discussed further in the further slide. With the project also compared the results between two datasets, which is MNIST and Cipher 10. And then we have proposed improvements to make the model perform better. Coming to our introduction, our main objective was the study what threshold. First to design and train CNN capable to identifying the images accurately, and the second was to experimentally focus and analyze how dataset complexity affects to model accuracy. Like let's take an example here. Why a simple dataset like MNHT gives near perfect results, but as we know, which is the Cipher 10 doesn't give all the training datasets. Coming to the further step, which is to understand how using TensorFlow at lower level gives more control over the training, layer customization, and experimentation, which is helpful for the researchers and the one who has he knows like what is important to do and what to do. And coming to the next slide, here we have used the tools and setup, which is a programming environment. For that, we have used our Google Colab connected, which is related and connected to Google Drive. And the frameworks are used by TensorFlow 2.x without no errors by direct use. And I've used Python 3.12 for the programming language. And we have used datasets such as MNIST, which is by grayscale handwritten digits, in particular by 28281. And we have used Cipher 10 with 60,000 colored images by 3232 by 3. And the hardware we have used is a GPU runtime in Colab because it gives a faster training when compared to other, and as we know the GPU is a free one for to the students as we do that. And coming to the next slide, here the Cipher 10 dataset preparation. So this dataset normally includes like 60,000 color images, which is small in size, that are mandatory to the Cipher 10 dataset by only 32 by 32 pixels. There are 10 class images including automobile, cat, aeroplane, bird, dog, frog, horses and trucks such as many. Out of the total in which 60,000, thus 50,000 are used for training and the remaining 10,000 we have used for the testing. Before video training, I have normalized all the image pixel values to the between 0 and 1 because it helps me to model learn faster, and also converted the classes labels into one hot encoded vectors because these vectors or the network can handle the multiple output categories. And the pipeline we have used here is TensorFlow or datasets which by shuffling and batching. Coming to next slide, the CNN part. Here we have used the model layers of overview by convolution filters, which is 32 filters by 5 by 5 kernel, and audio activation. With that, we have used max pooling 1 by 2 by 2 pool size, Relating of both C2 and max pooling 2. The C2s are 64 filters with 5 by 5 color run and with the same RELU activation. And with that max pooling, which is by 2 by 2 full size, as same as max pooling 1. And here fully connected layers or 1024 units with our ELU activation. And with that here we have done 50% of retention to drop out the max CNN octetator scale. With the output layer that we have our cipher 10 classes with 10 neurons. And the coming to the training setup, here we have used 5000 training steps with testing every 100 steps. Either we can do here with 200, 300, but for the precise and mandatory selectives we have used for every 100 steps by optimizing Adam loss by softmax cross entropy. With that, the batch sizes are the 100 images as I have mentioned in the intro. And coming to next slide where the CNN architecture diagram, which is connected layers to cipher 10 simplified. After the convolution and after the convolution and the pooling steps that we have done for the output future maps were flattened into a single long vector. This was this was then passed into a fully connected layer with 1024 neurons and again using RELU activation as I have mentioned there. With that we have done the kernel size of 5 by 5 using REL activation to introducing non-linearity because after that the max pooling layer with a 2 by 2 window reduced the image size and captured the most prominent features, and then we have gone to the second convolution layer, increase the depth to 64 filters with another 5 by 5 kernel and RELU activation because this helped me to model extract more complex patterns like textures and edges from the colored images. And here the flow of the CNN model showing convolution pooling fully connected and output layers for cipher 10 classification. And in order to say the CNN structure cipher 10 simplified is by input to convolution and pool 1, which is by 32 filter, and here the second one convolution and pool 2. Here the both the convolutions are which we have used are same. The remaining the pool 3 and fully connected to the outputs in total of 10 classes. And coming to next slide of which is our training observations and also known as training setup. Here for the training run for the 5000 steps, like using the mini batches of 100 images as I have told in the out of all the steps we have used and cross-checked for every 100 images. After doing that, I felt like we have accurately increased gradually to training. Initially accuracy, I can say it's approximately around 40% to 41% at the step 100. After reaching to 72% around step, which I have reached to 4700 steps. And coming to doing all the final accuracy after 5000 steps, I have reached approximately around 70%. But in this all accuracy find option, I felt and I found out that reached max to 72%, which is done by at step 4700. And this all training was done in Collab GPU to environment competition was fast and efficient. And the key insights for this network effectively learned color images features are used by performing the insights. And the performance was good for a small architecture but limited for like different and I cannot say different but it would be complex patterns. And coming to our comparison of part 5 with MNHT on Cipher 10, or let's take of a data set with MH type and final accuracy. Let's go for the first MNAST, which is type of grayscale digits. It has approximately accurated at 99%, but when compared to the Cipher 10, here we have used the color images, which is drastically low by approximately 70% when compared to MNIST. Because in Cipher we have used the color images and the MNIST by using the grayscale digits, it has gone through greater than the Cipher. After analyzing this final accuracy, the same CNN performed exceptionally well on MNST on Cipher 10. The shallow architecture could not capture the deep color based spatial patterns. And coming to reason for the observations of performance gap, the dataset complexity of MXT images are simple digits, whereas Cipher 10 images have complex textures and colors. In order to network depth with convoluting, the layers were sufficient for MNAST, but it is too shallow or too low for Cipher 10. And here this part of the project clearly showed that importance of model depth, data complexity with CNN performance. With that, the architecture worked for fine for the basic model, but to handle the real world images, it doesn't give that accuracy when compared to MAST, because there we have used the digit when compared to Cipher. Here we have used the color images. So I felt and I found like it was a reason that approximately it gave low when compared to MNIST. And coming to color and resolution, here the channels of RGB require more filters with features of hierarchies with deeper insights. And with this, the Cipher 10 needs more iterations and stronger regularization for training difficulties. Because at certain factors, we felt like doing all the accuracy to all the complexity with the data sets which they have provided with Cipher 10 and the MNIST are mutually not equal, but they came closer where it cannot even match equally. Yes, thank you. And from now I'll be continuing in the next video.